Hi everyone, today we're going to be looking at Shadows and adding that to our project. So Shadows within AWS IoT is sometimes referred to as digital twin. Basically it's a document that's stored on the AWS IoT cloud side or on the local Greengrass device that maintains a state of the device or any of the settings or parameters that you want. Within the Shadow document, you can see this is on the AWS site, the documentation, there's a concept of two states, so desired and reported. So the desired being, depending on which way around you're controlling the device, the desired being that we're going to turn our red LED on, and then the device would report back to say, yes, it's on or it's off. So then beyond that, AWS IoT will also tell you the delta, the difference between the reported and the desired, and you can subscribe to that topic. So I've just done a drawing to explain how it works simply on the device. So our Python component is going to communicate with the local Greengrass IPC, and that local Greengrass device will maintain a local shadow document. And then we'll use the Shadow Manager public component to synchronize the local shadow document with the cloud document, and that will allow us from the test console to actually control the LED on and off. So let's jump straight in, and I will log on to the device with Visual Studio Code again. So if you haven't seen how I've connected to this device, or you haven't seen the other videos, watch those in order to understand how I'm using Visual Studio device to connect to the device that's on my desk. So what we're going to do is create a new artifact on the device. So we'll call that Shadowy. And within that device we have to create the version, in that artifact we have to create the version. And then in that folder we'll create a new file, which will be our Python script. And then we need to copy across the code that I've already written that will be available on the GitHub repo as well. So just quickly talk through this code. We have we're using the Greengrass core IPC, as I mentioned. So locally we're going to request from this function, we're going to request the shadow state, and then we're going to look at that shadow state and decide if one of the desired parts, which is the red LED on, is on or off, and then actually actuate and turn the LED on and off. And we're also going to update the shadow with the status of the device. So in this while loop, you can see that we, first of all, we request the shadow document to see what we should set our LED state to. And in this, we're using a named shadow, which I'll touch on as well, what the concept of that is later. Then we are setting the current status to good and getting the value of the output or the input, in this case the LED is on, and then posting that back to the shadow state. So as a result, we'll have two parts in there. One will be understanding what our LED should be on or off, and also reporting back what it actually is. So in which case the delta document should always be empty because the state should be the same, but if something goes wrong on the device, we'll know that it's not actually actuated that. And what we might see is the other components that we're running that we built previously, like Blinky or Lighty, will be flashing on and off that LED, so the delta will actually fall out because something else is controlling that LED. So now I will add the recipe file, which we need to go with the artifact file. I'll copy across that code. This example is pretty much copied from the AWS website, so you'll be able to see this replicated on there. But within our recipe file, you can see that we are declaring the component itself. From an access control, we want the local IPC, which is Greengrass get thing shadow, update thing shadow, delete thing shadow. We're not using the delete, but I put it in there anyway. And from a resource point of view, we have, first of all, the shadow document for the device itself that is defined when the device is created, and then the named shadow, which is, I've called it my named shadow, which is the same as the AWS website example. And then in the manifest, we can see that we're just running that Python script, same as usual. And with the install, we're installing AWS IoT SDK. So we should be ready to deploy that straight to the device. So what I'm going to do, as usual, is open the debug console. So as usual, we will need to generate the debug console password. So to do that, we can simply go into here. Just paste that in. Yeah, because this is the first time I've opened it today, I've just got to browse to 1442 and then back again. This seems to only happen in Chrome. It doesn't do it in Firefox. Okay. So this should be exactly where we left it from the last video. Now, if we run the installer to install that component, yeah, and we can monitor that within the console. So usually I have this console open on another window, but obviously I don't want to share two screens because it gets too big. So we should see that the Shadowy component installs and runs. There you go, that's installing. So that's good, that's installed and we can see it running. So let's just pop back to Visual Studio, and so let's just open the log for our component. And we can see that it's trying to run the two parts, the setting shadow good and bad, but it's failing to do that. The reason it's failing to do that is because we haven't added the shadow manager component yet to the device. So let's pop back. First, we need to change the permissions for the certificate that Greengrass uses to connect so that the shadow manager can communicate with IoT Core and retrieve and set the shadow documents. So we can go to that policy thing and navigate to the certificate, go to that certificate, check the associated policies, and you can see that I've already edited my policy document to allow get thing shadow, update thing shadow, and delete thing shadow, and also limited that resource to just this account. So you will need to update your policy document if it doesn't look like that. So let's pop back to Greengrass, into Greengrass console, and go to our deployment. I'm going to revise that deployment to add in the shadow manager component. So you'll find that in here. So we do need to configure the shadow. Oh, that's on the other screen. We do need to configure the shadow manager component to tell it which local shadows we wish to synchronize to the cloud and at what frequency we wish to synchronize those shadows. So I didn't want to do that. So if I click that button, click configure component, you can see here that we can merge in a document here to say which shadows that we wish to synchronize and how frequently we wish to synchronize those documents with the cloud. So I've got that I can copy and paste in now. So hopefully you can see that. So what I'm saying that I've got this name shadow on the device, the my name shadow, and you can see the limits that are set within there. So the outbound syncs per second, the maximum request rate, and the maximum request per things. So this is there because if you're updating the shadows locally more frequently and you're using Greengrass with child devices that are communicating at high frequency, you don't necessarily want to sync those to the cloud all the time, and you might not want to sync any of those local shadow documents at all. So here within the configuration file, we can set that for the shadow manager. So I'll confirm that, go next, next, and deploy. And we can monitor the progress in this IoT job to see how well that rollout is going. But we can also see in the local debug console when that shadow manager component is deployed. I can see that started something there. There's a new coming in. Okay, and the shadow manager is now installed and running. So let's go back to Visual Studio and see if those errors have gone now that we've set that local shadow. Okay, that's good. So you can see now it's we're actually receiving the shadow status, which is there's obviously a blank shadow document in there, but we've set that within that. So if I turn my camera on, so we can see that it set the red LED on. I think that's just a byproduct of the state that it was in. So let's go into our console again and go to the device. So if we go to the device shadows tab, we should see that name shadow has been created. Yeah, so here's my name shadow. And because it was a new document, it's been populated with these default fields. But what we can do, as we're not using those, we can go in and just edit those fields out as we don't need them. I'll change this one to be red LED. And we'll set that to the value of 0. So we're going to say, okay, red LED, turn off. So if we update that, we should see the red LED will go off. Now, the way that the shadowy Python script that we've got works is that it's polling, so you can see the delays within the code. So within here we have some 10-second delays, so potentially it could take 10, 15, 20 seconds to go all the way around again after we're changing that. So you could increase the frequency of the polling to poll that local shadow document, or there is another way which I'll demonstrate in a moment. But we can see now that we have control of that red LED using the shadow document. So if I go back and switch that on, we should see the LED come back on, and the shadow document should update and report that that's on and the state is on. So there's metadata around the shadow document as well, such as the versions, which I think we can see. Yeah, so you can see the versions here of updating this shadow document. So I've previously been using this, but every time it polls or updates that value, it's going to update the version number of the document. And associated with this shadow document are the various reserved MQTT topics that I mentioned earlier. So you can subscribe to these topics and therefore get a faster response to say, okay, we're going to subscribe to the update accepted so that I know every time someone successfully updates that shadow document, I'm going to receive an MQTT message that we can dive into and see what's changed within that document. Or as I mentioned, the Delta document will be updated just to show you those differences between the desired and requested states. So let's jump back to the device again, and I'll show you an example of that where we subscribe to one of those topics. So what I'm going to do first of all is I'm going to stop the shadowy component because we're going to create a new one. So back onto the device, we're going to create another artifacts folder. So we'll call this one sub because we're going to subscribe. Within that folder, as always, we have a version, and then within that folder we'll create the file okay, and then I'll paste that code in. So here you can see I've subscribed to this reserved topic with my name shadow update accepted, and we get this callback which we can see on this subscription here. So pretty much the same as the MQTT subscription that we did in the other example. Exactly the same concept. We're subscribing to this topic, and then when we receive the callback, we will pass the JSON to see if the state desired red LED on is true or false, and then react to that. So we just need to create the recipe document to go with that. And then I'll copy the code across. So within this recipe, you can see that I am just subscribing to the local IPC. So this doesn't use the Shadow Manager at all. The Shadow Manager is managing and posting on these topics locally, but you don't need the Shadow Manager in order to use this part. Okay, so let's deploy that to the device. I can use this one in just okay, let's just check in there. Okay, that's not deployed, so let's see what I've done wrong. Maybe I didn't save the documents. Let's try that. ShadowySub. Okay, that was obviously it. I didn't save the documents. Could have checked the log to see that, but it was quicker way. Okay, so that's now running. So let's just jump in and test it straight away. So let me turn back on the camera so you can see the device. And there you go. So let's have a look. So the LED is on at the moment. Let's just switch that to off. And you can see how much quicker that is. That's instant. So as soon as I'm changing that document, this value. Okay, so there's two methods there for you to use, and I'll upload the code to the GitHub repository so you can play around and get that working on your device. I'll also put a poll in this video to see which components that you would like me to cover in future videos. So there's been some changes and updates this week and announcements. One of them is the public components or community components, and I'll just try and find those now for you. So here you can see that there is now this concept of community components, so we can cover any of these community components and add those to our Greengrass device. So Kinesis video streams, for example, we could connect a camera up to the Raspberry Pi and then stream that video feed to Kinesis using this component. Home Assistant, Grafana, local web server, Jupyter Labs, which is quite a good one for when you're developing Python scripts as we are on the device. You could do that within Jupyter Labs, so you don't have to keep redeploying the component. You could just do that within the Jupyter Labs document. And as well as these ones, you've also got the AWS provided components, one of which we used, which was the Shadow Manager. So you can find those on GitHub as well and use those. So I'll add some of these in the poll that I think are the most interesting, and if you want to vote for which one I should do a video on next. Otherwise, I'll see you next week.